are brought in front of the court because you are responsible of what you did, you cannot tell the judge that it was the program that was mistaken. It's your responsibility. So be careful, because this is a kind of new risk that engineers are facing. In the past, engineers were used to know everything they did because everything was done by hands. Now, the PC is doing a lot of calculations for us, and if we use a program that is pre-prepared, we run the risk of not understanding what we are doing. And this is risky because you cannot spot possible mistakes. Because if you understand what you're doing, you look at the results and you see if there is something wrong. If you don't understand anything, even if you look at the results, you cannot spot mistakes. So be careful. Anytime that you run a PC and you don't know what you are doing, be very careful, because you are exposed to a risk. So if the consequence of the risk is not very concerning, you can say, okay, that's fine. But if it is, be very careful, because there are plenty of examples of people that unfortunately made mistakes because they used wrong software, wrong programs. Okay, now, before moving forward, because we have a second question to address in this exercise, which is the computation and the plotting of the 90 yearly flow duration curves. You remember that for estimating the flow duration curve, you have two possibilities. The first one is what I just did, and we are done with the first method. The second method is that you compute for each year of the observation period a flow duration curve, and then you compute the average for each duration of the various curves. You remember what we studied at the lectures. Now, we have to do this, but before doing that, which is a bit more complicated because we have to draw 90 curves, before doing that, let me show you how to proceed when you want to save the sequence of instructions in a program. Because now what we did is to get a program that is pre-prepared by me and cut and paste it. But if you are doing something new, at the end of your day, you may want to save the instructions in a file in order to be able to rerun them one day later. So let's suppose that I want to do that. How to do that? Okay, first, let me clear the workspace. So first, let's save the history. Let me save my history. Save history, and let me give a file name to it, like march28.txt. Remember that if you do that, it is saved probably in documents. If you want to save in another directory, you have to give the full path. If you want to save it on the desktop, you have to give the full path. We already discussed the path issue. Okay? Now, if you just type save history, you may go to your document directory, and I go in my directory where it's saved, and I find there the file that I just saved, March 28. Let me open it with a text editor. You can double click over it, and you get Notepad opening it. Of course, your file will be longer because I removed everything just 5 minutes ago. So your file will be longer. Your file will not include the comment, probably. But this is what we wanted to produce. Of course, if you are saving at the end of the day, or already now, you have some lines that you want to remove. You may want to remove from your history because they led you to mistakes or they were not necessary. So I suggest that you clean everything you don't need. In my case, for instance, I can clean the first instruction, ls, because I don't need it. And if you want, I can also clean save history in order to get a clean file, and then I save it. Now, this is the file that I can cut and paste in R if I want to repeat what I did. Cutting and pasting is very handy, very easy, but still, you know, it's a bit, it requires selection, etc. It's a bit boring. So I want to give you another option for cutting and pasting more. It's a quicker option. So I go back to R. The other option is the function source name, file name. Good. I already did everything. And here I have my flow duration. Sorry. Car. Please do that, because I want that you fully understand how to save your work and reload it. In doing that, you already created a program. And afterwards, you run the program. You have run the program. I mean, it's a very important progress that we are making. This is how I produced the files that you find on my website. Precisely like that. I did the exercise and then I saved the history and I cleaned, I put comments if needed, I cleaned the file. Everybody did it. Can you raise your hand if you were unsuccessful so far? Okay. 3. Okay. Did you do it? No, 4 people. Okay. Are you still trying, or there are unsolvable problems?
Save history did not work.
Sorry?
Save history did not work, and I saved it by Control S. And then I have a file. I put source command.
Okay. And the source command doesn't find the file. Okay.
It found, but it doesn't work.
It doesn't work.
Unexpected.
Yeah, so for me it says unexpected signal.
Yeah, but did you try to open the file and clean it? Because you have to clean it. I think save history is not currently implemented. Okay, this is a Mac problem. So I know that Mac has another name for save history. So this is the problem. And so I think you just have to look on. Let me look on the web. And your problem, what is your problem? Just check save history on Project Mac. errata. Sorry, if you, in her case, she made a mistake while preparing the program, and R gave an error, okay? And if you save history, you also save the mistaken instruction. When it's repeated, it stops because it says, or maybe that it didn't stop. Did it stop or not? I think maybe that he got the final result anyway. Did you get a new plot, for instance?
No, because you
But-
didn't read the common
Okay.
source.
Anyway, you have to clean the file. Okay, you have to remove from the file all the instructions that were mistaken.
So, you say, you are also saving all the deleted commands. Or once you put
Okay.
Control F, you delete everything, but I think, sorry, I think like I say, here all the commands, and the is not including
Yeah.
the file. But sorry, this repeated, so let's check it again.
Yeah, but clean the file.
Exactly, but for cleaning the file, it's okay.
No, not here. You have to clean here. Not bad. So if okay, you have to clean here.
Yeah, exactly, no, but my question is, I think the commands, like,
Okay.
this command, then I save the save history, and when I change all the commands that they were already put in. So I don't know if, like, when they delete commands, I think, like, everything is in,
I'm not sure whether you opened the file, the right file. So I'm not sure if you don't.
I mean, it's working.
It is working, but in principle, if you clean the file, then you shouldn't.
You shouldn't, like, exactly, like.
Yeah, you shouldn't find. But did you save it after cleaning? Did you save the file?
Yes,
So I'm not sure if you clean the right file.
Yeah, how can we trim the file? I'm sorry.
You have to double click on it in Windows. So it's open with Notepad,
Okay.
and then you remove the lines that.
From our platform.
Okay, Notepad. You remove and you save them. Okay, now can I move forward with the next step? Did you solve the problem of save history? No?
I think if I work with RStudio, it would be better for me.
Ah, okay, okay, that's fine. Okay. Okay, now let's now pass to the second question. So now we need to compute the 90 flow duration curves. So let me just make a sketch on the blackboard to understand what we have to do. So far, our job was very easy because we created a vector of river flow. So we have this vector, river flow, from 1 to 32,850. We have our data, okay? data. It's one vector. So what we did is just to create a sequence of indexes, rescale them, sort the vector, and plot. Very easy. But if now we want to compute for each year its own flow duration curve, we cannot use the vector, because it becomes extremely complicated to look into the vector at the first 365 numbers, and then the second from 366 to 730, and so forth. It's complicated. So, a smart way of doing that could be to build a matrix from this vector. A matrix that in each column or each row contains the data of each year. So a matrix with 90 columns and 365 rows would be ideal. Okay, so from this vector, we have to pass to a matrix that whose indexes could be from 1 to 365, from 1 to 90. Or the other way around, rows, columns, the transpose of the matrix would be fine anyway. Okay? The important thing is to know whether we have to work in rows rather than columns. Is it clear? Because clearly, if I know that the first year or the 90th year is in the first row, this is fine. I know that I have to compute a flow duration curve for each row. Good. I have to be careful because if I think I should work by rows, but I should instead work by columns, I make a mistake, because if I work on the other direction, I make a flow duration curve on all the observation 90 of the 1st of January, which is meaningless. So it's extremely important when I create a matrix that I understand whether I should work in rows rather than in columns. Okay? Perfect. So let's create the matrix from the vector. This is easy. And the instruction is, even without looking at the text file, the instruction is, or let me look at the file because I want to use the same name for the vector. It's river flow 2. So river flow 2 equal to array. Array is a function to build an array. And the arguments are the name of the vector, river flow, the unsorted vector. I need the vector in chronological order. And then I have to give the dimension of the matrix, which is a 2 by 2. It's a vector with 2 dimensions. So let me give the dimension 36590. Good.
How do we clean history?
Clean history.
Because every time I open a new file, it says that.
CTRL plus L.
No, this is the workspace, Control L. Yeah. To clean the history, I don't know. I think I usually remove the file in the R directory. But, oh, okay, let me see. Clean history. this removes our data, and I don't think this is a good way of doing that. Or under Windows, I think you can use a menu item, like a clear workspace, something like that. And from the console, let me see, I think there is a, no, I think the only way is to delete the files. But there is no reason for clearing the history. I mean, it's you should always keep it, because it's a memory of what you did. But if you want to remove from the history some instructions, you can open the history file and edit it. Okay, so we got this array. Now, should we, let's try to check whether everything is working fine. So look at the array that we created. It has 2 dimensions, of course. The first dimension refers to the day into the year. The second dimension refers to the year. So if I want to show on the screen data from the first year, what I could do is to display, in terms of the first dimension, data from 1 to 10, and in terms of the second dimension, I just can put 1, which is the first year. Sorry, it was river flow 2. So in doing that, I get, for the first year, second dimension, the first 10 days. If everything was correct, these 10 numbers should be the first 10 numbers of the river flow vector. Let's see whether we get the same numbers. River flow 110. Perfect. You see the same numbers. This very simple check that I did is something that you should get used to do very frequently. It takes 1 second, and it's an easy way to check that you didn't make a major mistake. Again, try to understand what I'm doing. So first 10 indexes of the first dimension, first index in the second dimension. I never remember in English how to say this. It's semicolon. No, it's how to say in English the 2 dots.
Semicolon.
Semicolon. Yeah. Okay, so the semicolon allows you to specify a range of indexes. Okay, now we have the means to compute the flow duration curve for each year. Let me clear the workspace, and let's suppose that we want to compute, plot the flow duration curve for the first year. We can do it in only 1 line. Let's make this exercise, because it's a useful exercise for you. You have to learn how to play with R. So, plot. You remember that in order to plot the first flow duration curve that we did in this graph, we used a plot function. And the plot had the duration as first coordinate and the sorted vector in the second coordinate, we have to do the same thing here. And the duration, given that I want to refer the first year only, the duration is a sequence from 1 to 365. The river flow is the ordered vector of the first year. So, ordered, I said, sort. Now I have to put the vector here to be sorted, which is the first year. River flow 2, the matrix. The first index, let's drop it, and let's just put 1 as second index. Decreasing equal through. And then type equal line. Will it work? I don't know. Let's see. It seems yes. Yeah, it worked. This is the flow duration curve of the first year of observation. Fine. But we need not just one flow duration curve, we need 90 of them, remember. So let me see the array, but if you create the array, because river flow 1 is the vector, you need to create the array first.
Yeah.
You missed this instruction. Just 1 second, I display it to you.
The array from the vector.
Yeah,
Okay.
here, you are missing this.
Okay. Well, I think I did it.
I didn't see it on the
Yeah.
screen.
Maybe
Okay, but then here you have to plot river flow 2, not river flow 1.
yeah, okay.
Okay, sorry. I didn't see that you didn't miss it, actually.
Makes sense.
Okay, everybody did this. Okay, just follow me 1 second, because we did only the first step of our second job, our second task. Because, as I said, we need to display not only the first flow duration curve for the first year, we need to display 90 flow duration curve, 1 per each year. And let's look at this graph before moving forward. I see that this flow duration curve is different with respect to the overall flow duration curve, which is fine. because every year is a particular year. In this case, for instance, you can see that the max flow is not very high, because if you remember the previous curve, the max was 10,000. Here, the max is about 5,000, less than 5,000, so it's not very high. And also, the flow duration curve doesn't start from zero here. It started from the mean flow, which is 1,000, which is not bad. I mean, it's not very low. What is the problem? The problem is that I need to plot on this same graph the other curves. And this is possible. I will show you how to add lines in a graph. The problem is that if I add a line with a higher max flow, then it goes out from the plot. So the first thing that I need to do is to set the scale of the plot so that it contains all the curves. So I have to repeat this plot, because in this form it's not fine. It's fine in terms of the abscissa, because it's the same, from 0 to 365. I would be happier if I could put a 365 here, but this is something that is a bit forward, a bit complicated, so let's postpone it. But again, the abscissa is fine. I need to set the scale for the ordinate. So this is our first task. Redraw this with the correct scale. So in order to do that, what I need to do is to go back to the plot and let me see if I remember correctly. I think if we want to change just the y scale, I should write y lim equal c, and I would say that the mean is 0. The max, let's say that it's max of river flow. I forgot a round parenthesis. You see that it gave to me a plus sign, which means tell me some more, you forgot something, and I forgot a round parenthesis. And in fact, I got what I wanted to get. So this is something, just get aligned with me on this. This is something new for you. Because it's, you learn how to set the limits of axis. Okay, give me 10 seconds, I want to see what I did here. Okay, now we have to add the other 89 curves. Are you ready to follow me, everybody?
I put the plus 2, but I don't know what I missed.
Sorry?
I received the plus 2.
Twice, 2 times?
No, only once, but I don't know what I missed because I think I wrote everything. 5,
Okay, could you please add a second round parenthesis? After the plus.
Second round parentheses. I don't know if there are more.
I think you forgot, like me, a round parenthesis, and you have to add it. So you still have the plus. Yeah, but you needed a second round parenthesis. So Control C. Yeah, or let me check. Just one second. Okay, just put a second round parenthesis there.
Ah.
Okay. Okay. Now let's add the other curves, and let me do the second. Let me add the second curve alone for now, because we cannot do the same, we cannot repeat the same instruction 90 times. You understand that I need to speed up the process. But let me plot the second one, just alone for now. And in order to plot the second one, you have to use another instruction. I go back to the instruction plot that I used here. I add the parentheses that I forgot. But what we have to do now is not to use plot, but to use lines. The function lines adds lines to a plot. And you have to remove type equal line. You have to remove the limits of y, because it's already there. And then it should work. I'm not sure whether it was added or not. Maybe yes. Just 1 second, I want to check. No, I think there is something wrong here. Ah, yeah, because I forgot, I rewrote the same curve. Sorry, I forgot to change the index. Let me do that again. It's 2 here. Okay, that's it. So, in essence, I changed the instruction, it's lines. I don't need to say again that the graph is a line, because if I use the instruction lines, it's already a line. I remove the specification of the limits for the vertical axis.